For a lot of people, their first encounters with modern LLMs is shocking. A software engineer finds that asking coding questions to ChatGPT gives similar answers as junior software engineer would give. What takes a little bit longer to reveal is that, unlike a junior software engineer, ChatGPT is not slowly becoming a senior software engineer day after day.
Almost every architecture trained today uses something called the transformer, based around the backbone called attention.
Attention is based on remembering everything from the past.
In order to attend to some information, you need to remember it in perfect detail.
Whenever the context keeps getting longer and longer, attention becomes the bottleneck of the whole architecture.
Because current models get more and more expensive the more information you show them, what model providers do is a combination of arbitrarily discarding old information and hard cutoffs on how long a user is allowed to interact with an AI in a particular session.
For agents to really work, we need long context neural networks. Remember everything that worked and didn't work from the past, and to learn over time just like a human would. Today we're releasing Power Retention, the best architecture for long context modeling. Power retention is not a hack, it's a radical new architecture that massively reduces the cost of training and doing inference on extremely long context.
It allocates a fixed size storage, and new information is being compressed into the memory instead of appended to a constantly growing memory. We never run out of space.
The cost of training on one token of power retention is independent of the context length that it is trained on. We believe that neural networks based on power retention will be able to iteratively write and debug software just like a software engineer does.
There are many potentially extremely useful applications: code retrieval, legal analysis,
modeling videos hours long, or constructing agents that can stay on task for weeks at a time.
All of our research from the past year on power retention is going to be available for anyone to use. If you're using Python to do deep learning, for example in a framework like Torch, all you have to do is pip install retention, and all of our power retention code will become easily available for you to use on any NVIDIA device.
You're going to see that your long training runs become orders of magnitude cheaper, and you're going to see that inference does not slow down.
We're releasing architecture called Power Coder, a coding assistant model at the 3 billion parameter scale, which leverages power retention for lightning-fast local inference and coding autocomplete, to showcase the power of our new architecture. Finally, we're open sourcing Vidrial, which is our framework for writing GPU kernels that enable extremely hardware-efficient implementations, not just of power retention, but of lots of other CUDA kernels that you might want to write as well. Thanks to Vidrial, we were able to speed up over 2x from a Triton baseline on our power retention kernels and get 20 to 30% speedups over flash attention too.
We hope that by releasing it open source, the community is going to build around this ambitious goal and help us understand things that we haven't even gotten to try yet about this architecture.